This video is an overview of BigIdea2. Let me read BigIdea2 to you. Chemical and physical properties of materials can be explained by the structure and arrangement of atoms, ions, or molecules and the forces between them. So the whole idea of this unit is bonding. How is it that atoms and ions and molecules are arranged? What are the bonds between them? What are the intermolecular forces between them? And how do we tell those things based on macroscopic properties? So remember, part of the big thing of AP is thinking about how macroscopic properties tell us about microscopic things. We can't see bonds. We can't see electrons. We infer all these things based on what the macroscopic properties are. Can we draw pictures? Can we model what's happening microscopically based on what we see macroscopically? So let me quickly go through the learning objectives here. You can predict properties of substances based on their formulas. And again, provide explanations based on particle views. You can explain relative strengths of acids and bases based on molecular structure. We're actually going to get more into acids and bases much later this year, but we will get to that one. This one is you can use particulate models to reason about observing differences between solids and liquid phases and among solid and liquid materials. So think about what solids look like in terms of a particle diagram, what liquids look like in terms of a particle diagram, and how those things are reflected in macroscopic properties. What's the difference between solids and liquids? These here are all about gas laws. We are going to learn gas laws this unit, so we'll be definitely working on that in the next few days. This one is about solutions. How do things dissolve? How can things then be separated? Think about our intermolecular bonding chapter last year. We've definitely done these, but we will go over them again. The experiments here are filtration, chromatography, and distillation. We will do a chromatography and a filtration in this unit. This one's, again, about intermolecular forces. This one's about the particular one of London dispersion. This one is again about bonding. This one's gases. Again, we'll be doing that. This one here in the middle is polar molecules and attractions between particles. We'll be doing a lab about that too. This one's Coulomb's law for ionic things, and again, how ionic things dissolve in water. This one's why things are ionic. This one's about why ionic things dissolve in water. And this one is more intermolecular forces and how those intermolecular forces manifest themselves in macroscopic properties. This one is predicting the type of bond based on where things are in the periodic table. Pretty sure you know how to do that already. This one's figuring out bond polarity based on where things are in the periodic table. We definitely have done that before too. Students can create a visual representation of ionic substances that connect, right, more microscopic to macroscopic. This one's specifically for ionic things. This one is metal bonds. This one's Lewis and Vesper, so you might want to review those. And this one is a lab question. This one says you can figure out some kind of experiment to do to determine what kind of bonding a solid has. This one's more about what do ionic solids look like? What do they look like macroscopically? What do they look like microscopically? This one's about more metallic bonding. What's an alloy look like? What's a pure metal look like? Same idea here with covalent solids. How are macroscopic properties connected to microscopic properties? Same idea for those. That's it. That's all a big idea too. So those are the things you want to think about. All the times we talked about how the microscopic properties, the bonding and so forth, are determined based on macroscopic properties that we can see. Melting point, boiling point, dissolving, gas laws, being able to write particle diagrams. Those are the things we will be focusing on in this unit.